Get started. Today, eWorld Enterprise Solutions is doing a workshop on the introduction to AgenticAI development. This is complementary to the AgenticAI workshop by Microsoft, and then also Model Context Protocol. I don't know what that is, but Yifan is going to be telling us what that's all about. So I'm going to turn it over to him, and we'll spotlight him. Typically, we'd like you to, and again, Yifan, you can answer this question. Do you want people to raise their hands and ask questions? Do you want them just to turn on their mics and ask questions, or do you want them to put questions in chat for you?
Sure, yeah.
Oh, all of the above. So if you have questions while he's talking, feel free to raise your hand. There's a little raise your hand icon at the bottom. That gets my attention, and then I can interrupt if you don't want to interrupt yourself and just go, hey, Yifan, I have a question. Otherwise, we'll get started. Okay, turning it over to Yifan.
All right, thank you so much, Selma. Yeah. Hi, everyone. My name is Yifan Zhao. I'm the lead data scientist at eWorld Enterprise Solutions. So basically, we are like one of the major contractor to the state of Hawaii to deliver cutting edge technical solutions for for definitely now AI and machine learning features, but not limited to. Also like more broader software and service platforms. So we have a very deep connection with Hawaii. We are also located in Hawaii, Honolulu. Yeah. All right. Yeah. So my presentation today will be an introduction to agentic AI development and the model context protocol. So I understand that this would be more of an industrial topic. And you might not, like the universities or the academic might not be so enthusiastic about this engineering and industrial topics. So I hope that will be something refresh for you, and also however, super useful, for our current AI and machine learning industrials. And also I understand our audience today would be computer science undergraduate is computer science students. So I will keep the presentation like a high level and focus on the direction development and to try to attract you, try to interest you to this direction, because this is the cutting edge of agentic AI, and based on generative AI and large language models, usually so-called as ChatGPT, but ChatGPT is only one product from one company, OpenAI, and it's actually a whole type of machine learning models, large language model or transformer-based models. And we developed this whole new world with that model, and started open our doors to more fancy and super convenient features. Okay. So that's pretty much about the introduction to this introduction presentation. Okay, so let's get started. So our first thing want to introduce is definitely the basis. Everything's basis here, generative AI. So generative AI, when we talk about it, we are usually referring to a class of artificial algorithms or machine learning algorithms capable of generating content from its training data. And this usually includes text, images, music, and more. So it started from text. So that's why people usually call it large language models, LLMs. But now it's already capable to also generate other modalities and types of data, such as images and music, and other modality of data based on the patterns it learned from the training data. So this the most important thing is these models are significantly transforming like various industries, including our like computer science, like software engineering, and every other software or internet-based services. By automating content creation and content generation and enhance creative processes. So then, what is generative AI? So to answer that question, we have to get back to one of its like I would say it's a parent area of the currently highly like frequently referred to generative AI. It's the NLP, natural language processing, because the model of generative AI, the model of transformers was actually from this area, natural language processing. So natural language processing is basically focusing on enabling computer or algorithms to understand, interpret, and generate human languages, the natural languages, that is the text data. And so because NLP, like natural language processing, works with text, and that is, I would say, actually the most straightforward, the type of modality that we human understands the most among, for example, other modalities such as images or audio, like musics, or other like modality. So that's why in my understanding, the generative AI was born from natural language processing. So because it's from this, so our the starting features that we are leveraging generative AI is including understanding human language to process and interpret text data, and generating coherent text, enable like AI models to produce human-like text, to write novels, to write poets for us, and also other applications such as machine translation, sentiment analysis, and more importantly, chatbots. Like now many of the services you leverage on the internet is already conversational, so they are technically all chatbots. Uh, and then from natural language processing, this is the first model that we can call it as generative AI is the transformers. So transformer is a neural network architecture. You might heard this term neural network, also deep learning. That kind of revolutionized the field of generative machine learning or NLP areas. So basically, I would say they revolutionized the area by two things. One is the parallel processing, because comparing to the previous, like the earlier natural language processing models, they are much easier to be parallelized. And also the second thing is the attention. This term you might have heard like frequently. Attention maybe could be the very fundamental that enables the machine learning model to have some so-called intelligence. It allows the model to focus on relevant parts of the input sequence, to have some relative focuses or some ignoring some less important parts. That's why we call it attention. And also because the attention component is so easy to be parallelized, so it can be scaled to huge models and to handle large data sets and complex tasks. So then here we can have a quick glance of attention in transformers. I understand this is a very deep research paper published in 2017. And as you can see, the architecture of the model. This is the architecture of the attention, and this exact architecture later is referred as encoder decoder architecture. This is like a kind of complicated architecture, so I wouldn't dive too deep into this, but one one way to understand it is uh, this is the exact component of the so-called self-attention, the multi-head self-attention. How it works, we usually interpret it, explain it with a metaphor. It's like a dictionary. So we are trying to look up in the dictionary with a set of keys and a query. So the query is just the input here, and we are using this query to try to look up in the dictionary to try to match the other keys in the same sequence. And that's how the attention generates, because, for example, in a sentence, there are like a certain more relevant or less relevant pair of words. For example, my dog names Gogo. And then in a sentence, Gogo is a dog. Gogo is a Westie, is a West Highland White Terrier. So the word terrier would be more relevant to the word Gogo, because in the human understanding, Gogo is the dog's name. So that's like a relatively more relevant words and less relevant words. That's how we look up into the attention like a dictionary. So that's pretty much of it. I don't want to dive too deep into this. This is a bit of the research, cutting edge research paper. All right, so then one milestone or revolutionized variant to the transformer models is this GPT. So that is the model ChatGPT is based on. So ChatGPT, the GPT, generative pre-trained transformer, is actually a variant of the architecture that we just saw. And this variant is only half of the original transformer model. It's decoder-only architecture. And if you can, if we go back to our previous slides, we can see this is only half of the architecture. And with this only half of the architecture, it's actually like achieving more than double performance, because it have a kind of a new paradigm that for generating text, and it's trying to predict the next words. It generates text by predicting the next words in a sentence. This process, we call it auto-regression. And that's kind of the key why GPT models and also the later decoder-only models achieved so far and so much in our end user usages. So this is the key. Next token generation. Like models like GPT, the model only predicts the most likely next word in a sentence, in a sequence based on the preceding words. And that is the very fundamental of, I could say, all the generative AI or large language models is based on nowadays. Um, okay, so now we have the a standalone generative model or large language model. What else we can do? Or how we can further improve it? Because one famous issue with the generative AI models or large language models is hallucination. Because it has, you don't know what training data it has, and you don't know how it's kind of integrity and mixing and merging its training data. So we cannot control it 100%. We don't know either the generation from it is accurate or not, it's true or not, it's real or not. So that's why we introduced this new technique called retrieval augmented generation, RAG. So RAG combines generative models with retrieval mechanisms to improve the quality and relevance and reliability, credit, the fidelity of generated content. So in RAG, we given the query, then we retrieve from a database. In the database, it's all real data. It's all real documents. It's all the ground truths that we already checked by humans. And then we fit the query plus the retrieval together into the AI, into the large language model to ask it to generate it with the augmentation of the retrieval data. And then this generation is significantly improved with in terms of reliability, its truthness, its faithfulness, with the support of the reliable retrieval data from the database that we human already verified. So then from RAG, we have a new concept called Agentic AI or AI agents. So Agentic AI is AI systems that can autonomously plan, make decisions, and execute tasks across multiple systems to achieve specific goals. Like key one key characteristics of AI agents comparing to like a standalone LLM is AI agents can interact with various tools, data sources, and APIs to accomplish complex tasks. And go back to the last slide here, the RAG, the vanilla RAG is actually, I would say, the most the simplest AI agent, because here our LLM is actually calling the tool of the retrieval mechanism. It might be a search index, it might be a vector database, or it might be just a document corpus. This is the first tool for the LLM. And now here we are enriching this concept with agentic AI so that it can not only simply call a database with the trustful documents, it can also autonomously planning what methods or what strategies it needs to or decide what kind of tools it needs or what kind of, for example, we have multiple databases, what kind of database it needs, what kind of data it needs, and decision making. So to decide what is its next step, what is the next tool it needs, and then finally after the generation, it can not only generate the text and for our reference, for our humans reference or reading, it can also call the API to carry out tasks or execute the tasks to actually do things, do actions on behalf of us, on behalf of human. So yeah, this is the concept I just described, that AI agent is one step beyond the RAG. So RAG could be seen as one of the earliest attempt to build agentic AIs. And now, like one of the most frequent applications that we are leveraging agentic AIs, maybe like as you are computer science students, you might leverage, for example, GitHub Copilots. So GitHub Copilot can like implement codes for you, can like answer your question, can look for documentation for you for whatever questions you have, maybe regarding a package, regarding an algorithm, regarding a functional that you are trying to achieve, you are trying to implement. And then it can also debug it. If the code doesn't work, you can send the error message to it, and it will try to debug it to try to look up into the documentation, and it can also test it by itself if to check if the debugging worked. So that's a like most frequent example of AI agents in our like in our daily life. So then like here I'm showing an example of an AI agent. This is Microsoft Copilot. It's not GitHub Copilot. So this is more general. It's not for coding. So I ask it a like a more general regular life out of work question. I'm asking it to come up with a 1 week travel schedule to Hawaii, and I ask some like more detailed requirements like the landscape size, options of flights, options of hotels, and the commuting options among all the sites, and also in the end, I ask for a simple route map for the landscapes or for the hotels, the sites that I have to go, that I want to go in the trip plan it generated for me. So here it's a part of it, the response. It's trying to formulate this trip plan for me. Day one, day two, let me go to next slides. And also the commuting options, rental car, bus, taxis, or Uber, Lyft. And in the Maui Island, also other options, maybe shuttles. And then most importantly, the route map. I'll show you later. And here we can see these are actually the links, the reference links it's trying to give. And these links are like a real website links. I can click to Hawaii Airlines to book my flights, and some like blogs about which airlines or other options. And then also more importantly, it really can generate this route map for me, because natively this large language model is only a language model. However, like I'm asking it to generate this map, this diagram for, this diagram for me. Even though this is definitely not a good diagram, but here we are we are looking at this capability that this functional, it can really respond with some other some other things that it cannot achieve with simply or vanilla language modeling or language generation. So it definitely needs something else to generate this, to respond me with this. And how did it do it? Here's a diagram that I formulated for it based on our like a Euro agentic AI development workflow. So given the user query that I asked it to generate a 1 week trip plan in Hawaii, it will first search in the internet about like Hawaiian travel plan, like what flights, what airlines, what hotels, what landscape sites, what hiking trails, for example. And then in the LLM, it will formulate the Hawaiian travel search results to a complete schedule, like day 1, day 2, until day 7. And then it will call most probably another LLM call, another LLM instance to convert this schedule to a diagram drawing request payload to a diagram drawing API, because the large language model is still a language model. It can only generate text. Even though now we have viral transformers that are virally capable generative models, but the model generated images are definitely not look like this. Like these are some diagrams that we need. For example, if I wanted to generate a rigorous diagram, a serious diagram like this, I definitely cannot use viral transformer models. It definitely still have to call a diagram drawing API, such as LucyChart or draw.io on Google, this sort of APIs. And with valid diagram drawing request payload. This is the more important capability it can do. And then it will assemble the travel schedule and the diagram to a complete response to me with both of this, the text travel plan from day 1 to day 7, and then the diagram with maybe each item here is a destination, is a landscape site or the airport, the hotel, this sort of concept of diagrams. So then now we've seen a relatively complete example of an agentic AI. So an agentic AI can do many things for us. It's very convenient, and also I would say actually the most valuable application of of generative AI models or large language models, or even across the machine learning area. However, we still have some challenges in developing agentic AIs. One of the, or most importantly, is the complexity in integration. So for us to connect the AI agents or the LLM instances to various tools and APIs can be complex and time consuming. So let's go back to the example we just saw. Here, maybe the most important tool here is this diagram drawing API. It has to convert the text schedule to a valid diagram drawing request payload. However, we know LLMs could be creative, and in other words, it can be unreliable. It's random. Sometimes it can generate valid codes, but sometimes it generates codes with some issues. So if we have to work on this, for us to work on this, it takes definitely efforts and time to tune the LLM's generations and also maybe work on some post-processing for the payload it generated to make it working. That's definitely a significant complexity for us in developing agentic AI. And also ensuring agents to have access to the right data at the right time. That's also the extra work we have to do, and also scalability, definitely. So because in the agentic AI system or in the agentic AI application, let me go back to this example again. You can see there are quite a few communications, either between LLMs or between LLMs and other tools. For example, here is the internet search or the database and the LLM. And here is between LLM and LLM. And here is between LLM and other APIs. So these are definitely some communication costs, both time and computational burden. So that's definitely also an issue we have to address, that is scalability. So here, that's why we are introducing one more new concept, model context protocol. So that is what MCP can help. So MCP is an open standard designed to allow AI models to seamlessly access external context from various sources such as databases, files, and APIs. It's open standard, so now we have MCP supports from, like, I would say most of the mainstream service providers like OpenAI, Anthropic, Google, Meta, Amazon, they all have it. And also most importantly, MCP enables us like a convenient access to the external context. And by simplifying the integration of connecting the models to other external, not only data sources, also tools and other APIs. So then for us, developers or computer science students, the benefits of using MCP agentic AI development are definitely so that we can focus on AI logic, and it will be reduce the integration efforts for us. We don't have to reinvent wheels every time. And also definitely improve the scalability because the communication in MCP and also between MCP and other tools have been optimized. So it's definitely a better scalability. This is also how MCP simplifies agentic AI development. So basically, MCP provides a uniform way to connect AI agents with various tools. And so this is a bit like high level. So to give you some more detailed presentation demonstration about MCP, here we can check some key components in MCP. So one is MCP clients. MCP clients are software components that enable AI models to interact with MCP servers, and MCP server we'll talk about later. And they facilitate communication between AI models and MCP servers. So basically, MCP clients are the ones that actually communicate with AI models. And what we have as the center is MCP servers. So MCP server is like the manager here, it's the orchestrator here. it manages access to external tools and data sources. That's the most important thing we want. And providing a consistent interface for the AI models to communicate, to interact with the external context, including both data sources and tools and APIs. So how does it do it is two things. One is request translation and structured responses. So basically, MCP does the request translation for us, because otherwise we have to do it manually to translate the request from the AI models, to post-process it, to make it valid for the external tools, so that the external tools can understand, and also the structured responses. So from the external tools, we also have to work on to post-process the responses from those tools and APIs to make sure the AI models can easily understand it, or like it could be the exact expected way that we want the AI models to read it, and MCP also does this for us. So here's an example to show you what are the extra efforts we have to do without MCP, or in another words, that what are the efforts that MCP really did for us. So this is a code that I really worked. This is part of my work, but it's not sensitive. So definitely you don't have to worry about anything. So here, this is a request body. This is JSON, you can tell. This is the work before we leverage MCP. This is the request I had to manually code and make sure the AI agent can understand, and it contains everything the AI agent needs, and also in return, what the AI agent generated to call the tool, to call the functions, I have to make sure it has everything that the function is expecting. It has everything valid that the function needs to return the correct results. So this is really time consuming for us to work on, especially if we have multiple tools to work on. So but with now with MCP, we don't have to code this ourselves anymore. So I can show you something else, some other examples with MCP. Now it'll be a lot easier for us. And so what else the MCP can do is also like a tool discovery. It not only like that we have to specify the tool the AI agent can access. The MCP also like can automatically discover the tools for us to connect the available tools and resources to the AI agent. And also definitely the connection to the resources and databases. Yeah. So here is an example that after we leverage the MCP. So instead of that, we have to code like the detailed JSON request and response payload or body. MCP does that for us. So this is an example on Google Cloud's MCP support. And so with MCP, we can just create an MCP and fit our tool, whatever our tool is. Here is a RAG tool to the MCP. And also the MCP can discover the tools for us with some methods and connect it to the AI agent. So that's in the agent application, we can simply call the MCP, and we don't have to call like various tools and set up ourselves. So here's a real world application of Agentic AI with MCP. We can simply imagine that it can be super useful for automated customer service, supply chain optimization, and financial analysis. So here, this diagram I'm showing it's a automated customer service agentic AI application with MCP. So basically, what we are doing here is with the customer, like for example, customer calling, we can have a live AI assistant. We can have like a dynamic resource orchestrator with AI, and also like some pre-evaluation um, agents for our human agents to help our human agents to save more time and enable to help more customers. So this is super helpful for like our real world applications. Okay, so then this is an overview of the architecture of agentic AI applications with MCP. So as the brain, we have the AI agent, and as the core, like the orchestrator, we have the MCP server, and then the MCP client plays as bridges between the MCP server and the AI agent. And then, of course, MCP server connects to various external tools and data sources for our AI models. Okay, so yeah, here's the to conclude this presentation, the future of agentic AI is really MCP, and also MCP also has a very open future with opportunities for innovation across various industries. And it really can provide increased automation, enhanced decision making, and new applications in like that are emerging in like across multiple industries. Yeah. Okay, so I'll have my presentation here. So this is a brief introduction for agentic AI and MCPs. To help, hopefully it will help you to get some interest and to attract you to this area in your computer science journey. And because this is really something emerging, and we are having a very good expectation for it. Yeah. All right. Yeah. So thank you so much, everyone. Thank you, Selma. So I will pause here to if you have any questions.
Questions or other things for Yvonne?
Yeah, so also please feel free to ask me any questions about myself, about our company, eWorld Enterprise Solutions, or our team, because I'm the leader of like a very, I would say, very exciting and enthusiastic team with data scientists and machine learning engineers, we like innovate exciting things with AI. Yeah. Oh,
So
sorry.
we do have a question here
Mhm.
from AS Angie, I guess. We want to learn more about developing AI agents. If we want to learn more about developing AI agents, does UH offer courses on this, or are there other learning sources that you recommend?
Okay, sure. Yeah, that's a great question. Yeah, so we definitely want to learn more about like AI agents. That's because this is a new thing. So I kind of doubt there are like any university courses uh relevant to this, but sorry, I'm not sure if University of Hawaii has any relevant courses for this right now. But for other learning resources on the internet, there are definitely plenty of them. And I would recommend to try with Google Cloud because Google Cloud has a relatively comprehensive SDK, development kit. They just call it Agent Development Kit. So you can develop your own like agentic AI applications, and also they have MCP supports, and it has a complete documentation for you to with quick start and tutorials for you to follow to try to code yourself. And I think Google Cloud has some like academic credits so that you can also leverage some of their resources for free during your like undergrad or graduate journeys. Yeah.
So, Yifan, I just invited you to our Slack network and to the eWorld channel. Is it okay if I suggest to people that they can put questions in there for you as well?
Sure, absolutely. Yeah.
So
Mm.
just so everybody, heads up to everybody, this is going to be a very AI centric year for the hackathon. So AI is going to, you're going to actually probably be creating AI tools for not every one of the challenges, but at least half of them, maybe 3/4. So this, Yafan will hopefully be a resource if you have questions about this. Microsoft will also be a resource. Google will be a resource. They're all doing workshops on the topic. So please plan to reach out to either Yafan or one of the other groups if you decide you want to use their tool set to develop your solution for the coming event.
Yeah, sure. Yeah.
So thank you, Yafan, for planning on.
Sure, absolutely. So please feel free to share with me the Slack link.
I've actually sent an invite to you
Okay.
to your eWorld email. If that's not the right one, you can let me know. So.
Sure. Yeah, sounds great. Yeah.
Hey, whoop, there's another comment here. Oh, hang on. Oh, I think that Angie was just saying thank you.
Yeah. Thank you, Angie. Yeah.
And anybody else have any questions or thoughts? So Yafan is on the East Coast, the mainland. eWorld, I think, started in Hawaii and has spread out. So you have opportunities potentially someday for working with eWorld in Hawaii, or do you have people on the West Coast too, don't you?
Yeah, we have people all across the mainland, West Coast, East Coast, and in the Midwest. Yeah,
So,
and of course, most people are still in Hawaii.
Yeah.
Yeah.
So, but quickly, just give us a quick overview of what eWorld does and why these tools might be valuable for a future eWorld employee, and finalize it by saying essentially who you're, a little bit of a brief overview of who your type of client would be or customer.
Sure, sure, absolutely. Yeah, so eWorld is a solution provider, a service provider, for mostly for the state of Hawaii, like the state government agencies and departments, mostly for social benefits. So we care about people, we care about people's living and welfare. And for example, one of our biggest client is DHS, the Department of Human Services. And we help them to build benefit systems and to try to automate things, intelligize things to try to help more people get their rightful benefits quicker and sooner. So for example, how AI agents or agentic AI is helping in this step is because previously, for example, with the human agents evaluating, for example, benefits applications, it really take some time and efforts for the human agents to evaluate everything, to verify everything and to make the decisions and also send the benefits to the applicants. But now, like with the agentic AI systems and other automatic systems that eWorld developed and delivered for the state of Hawaii, we can have many processes automated, like the application, the verification, the evaluation, and also the benefit uh, deliver. Yeah. So that's really saves much time, and time is life here because like these are about people's lives and welfare. Yeah. So that's how we help the community of Hawaii and the people in Hawaii to like with our technology and like AI, new AI techniques. Yeah. So then like possibly to attract you to work with eWorld after your graduation. Yeah, so we are this is the team I'm leading, the data science and AI team. We are a new team, and we kind of do all the data science and machine learning works and features in eWorld. So we have a lot of exciting opportunities from multiple departments of state of Hawaii and also some other agencies across the mainland, and to help the like for one example is with the human services for like the benefits and assistance, and also to help our children with child support programs. These are like multiple things we are helping for human welfare, with our AI knowledge.
Well, so if you're in the computer coding world and you want to do something with social interaction, it sounds like eWorld would be a good place to check out. So thank you for the clarification on what you guys do. I probably have heard the story before, but that was the clearest I ever the clearest I ever remember it being. So thank you, Yafan, today.
Sure.
Any other questions for Yafan before we call it a day?
Yeah.
Again, I apologize to everybody for my slow pickup here. Not typical of me. My phone didn't buzz to tell me. It usually buzzes a half an hour in advance, so I don't do what I did today. So forgive me all. I hope that you got a lot of good information here. And Yafan, thank you for your time.
Sure, no worry. Absolutely. Yeah, thank you so much, everyone, for being here.
And thank you guys all for being here too. So we appreciate your taking time on a Saturday morning, taking a listen. So, all right, well, that's it for today. I will put close the recording.